we're going to make a graphic organizer, in a way, about the states of matter. So what you're going to need today to start off with is a pencil, all right, some kind of straight edge if you want to make straight boxes or something, a ruler, something like that. And then if you want to add some color, go ahead and grab blue and red pencils or something to kind of symbolize cooling down blue and warming up red. So we're going to start today by making or getting a blank sheet of paper, all right? Or if you have notebook paper, you can use that. And we're going to turn it sideways, or we're going to turn it landscape here. And I'm going to check periodically just to make sure that we're all in the frame here. So we're going to start today, and we're going to think about what are the three main states of matter. And then we're going to add a fourth and a fifth state of matter from your vocab list. A lot of these words that we're going to use today are going to be on your vocabulary list. So let's go ahead and get started. I'm going to start down here with a box, about right here. Let's just say right about here. So if you want to go, make it nice and fancy and straight edge, that's fine. You can do that. Or you can just freehand it and do a box that way. I'm going to start down here, and we're going to write solid in this box. Okay, so this is the solid state of matter. And let's go ahead and write a definition for that. Definite shape and definite volume. All right, so there is the solid state of matter. Next, we're going to go up kind of a staircase here, okay? And I'm just going to start freehanding mine just to show you how you can do this. So about right there, we're going to need a box there, okay? And I'm going to go ahead and draw another box here. And finally, another box here. And we're going to need another box down below here, like that. So we're going to have 5 different boxes on this going up kind of in stair steps from the bottom left to the top right of the page, so it kind of makes a diagonal line. Okay, so we started with solid, so we kind of have an idea where we're at. Now, the next phase of matter, as we go up the staircase here, is going to be liquid. So let's write liquid up at the top, and then think about a definition for those. So liquid has no definite shape, but it has a definite volume. All right, so a liquid has no definite shape, but a definite volume. And then we're going to go up one more, and we get to the next state of matter, which is gas. And this one, if you think about a definition, no definite shape and no definite volume. Remember that? So as we have our 3 main states of matter, there we go. Now let's go ahead and put a title here at the top, and let's just write states of matter. And if you want to, let's go ahead and just write EQ3 on that as well. So what are the states of matter is our question. So we'll just say EQ3 states of matter. Now we're just going to work within this little box here for right now. All right. And before we get into the different changes of matter, let's go ahead and draw kind of what the particles look like. Sorry, my dog's barking in the background. Let's draw what the particles look like in a solid, in a liquid, and in a gas. All right, and then when we draw particles, we just draw them as little circles. Maybe we'll draw some motion arrows or things like that. So let's start with a solid, and let's go ahead and draw the solid particles below it because we're going to need a little space for this stuff. So I'm going to draw these solid particles as just circles, kind of a 3x3 thing. They're moving a little bit, but they're in fixed positions. So I'm just going to draw these motion lines here. If you want to draw kind of dotted lines between them, like they're kind of stuck to each other, there you go. Okay, so that's like solid particles there. Liquid particles are going to need a container. So I'm going to draw a little beaker here, all right? And then we'll put our liquid particles in here, and they're kind of flowing around each other, aren't they? And if you want to draw these particles, you know, pouring out of something, that's fine too. But the liquid particles will take the shape of the container, won't they? So maybe I'll draw a few more. All right, gas particles are a little different. Gas particles are flying all over the place, aren't they? So I'm going to put these motion lines here, right? So maybe they're flying around like this, bouncing off each other. These are gas particles. All right, if you want to color those in, cool. Grab colored pencils, why not? If you want to shade in those particles, just make them green, I don't know. Let's do that, add a little color. Do the particles there, and then these particles over here. Remember, the particles are atoms. That's what we call, that's the name of these little particles, and that's why we draw them as little spheres. All right, there's a little color to that. Feel free to add color to any of this. It helps you remember it better. And there you go. Now, these two boxes we'll get to in a minute. Before we do that, we're going to start putting in the changes. All right, so when we go, these guys are kind of blocking it, I just realized. So maybe we'll kind of move that around a little bit. We'll make it make sense here. But now we're going to put the changes in here, okay? And every time we go up, I'm going to use my red colored pencil because it's increasing energy. And anytime we go down, it's decreasing energy, all right? So to go up here, let's kind of start here and just go like that. And we have going from a solid to a liquid. So think about, what do we call going from a solid to a liquid? Melting, right? So as the particles start moving faster, you turn from a solid to a liquid. And then what do we call going from a liquid to a solid? I'm going to use our blue one. Called going from a liquid to a solid, freezing. All right. So that state change there is freezing. So now, right now, just look at solid, we have the particles, liquid, we have the particles. Solid changing to a liquid, we've added melting. Liquid changing to a solid, we've added freezing. Now let's turn from a liquid to a gas. All right. And then from a gas to a liquid. Check to make sure we can see that. Yeah, we're good. Okay, so when we go from a liquid to a gas, we call that vaporization. That's that vocab word, isn't it? And when we change from a gas down to a liquid, when we cool down a gas and we turn it back to a liquid, that's called condensation, isn't it? So let's add that there. All right. If you want to make these stand out, you know, you can add little boxes or little flags around them, you know. I don't know. Whatever you want to do. Make them stand out a little bit. Especially if your drawing is getting a little condensed together. So I'll just make them look like little flags there or something like that. Got it? Good. Now, if you want to go ahead, I mean, you can do this even. You could shade in those little things. It's probably not going to show up too well on the drawing that I'm doing here, guys. So bear with me on that. But you could shade in freezing, condensation, maybe blue. This is helping us remember that these are speeding the particles up. These are slowing the particles down. All right, so there's the three main states of matter, isn't there? But let's add a few more, okay? Let's add this guy. When we electrify a gas, we add energy in a different way. And that electrified gas is called a plasma. So our definition there could be an electrified gas. It still has no definite shape and no definite volume. If you want to add that in there, that still does apply there, except it's electrified. And we can add that and that there. Those state changes. These are all the state changes here. Okay? And we have a name for this. When a gas turns to plasma, this is not a vocab word, but if you want to add it on there for you completionists who want to know, I'm sure you're out there. That's called ionization. I-O-N is an ion. So ionization. Kind of like this is called vaporization. This is called ionization. And then the really fancy word for a plasma turning back down into a gas is called de-ionization. So if you want to add that. We see this when we turn off the lights in a classroom. That gas inside of a light bulb turns from mercury vapor and other noble gases into a plasma. When you flip the light switch on, you're ionizing it. And then when you turn the light switch off, you're taking the electricity away. So now it just turns back down into a normal gas. And you could shade these guys in because the red ones are adding energy and the blue ones are taking energy away, if you want to think about it like that a little bit. Okay, got that? Now, plasma particles, if you want to go ahead and draw those, they're like a gas, except they're electrified. So maybe I'll show them lighting up a little bit, and I'll add like a plus and a minus kind of thing here, because they have a plus and a minus charge, these particles do, and they're lighting up. There you go. Color them in green if you want to, just to show what those particles are doing. So there's up here in the high energy zone of these states of matter. And why not? Since we're at it here, let's go ahead and make a banner for this guy too. Just makes it look better, doesn't it? All right, so here's the states of matter. Now we're going to go down in solid land, and we're going to keep on taking energy away, except it's really not turning a solid here, okay? This is just kind of another change. So I'm going to go ahead and say, put kind of like an arrow here. I don't know, something like that, where it kind of takes a turn where it doesn't exactly go from a solid to this stuff. This is just kind of really from a liquid in a way to this. And this is the Bose-Einstein condensate. I'm not sure if you can see that there. Yeah. Bose-Einstein condensate is that fifth state of matter that we're going to learn about. And this is a, let's just say super cold super atom. All right, and this really doesn't really go into this whole staircase here. It's kind of off to the side once again. But still, we can try to draw those guys. All right, what happens here is the atoms all become one super atom. So I don't know, I'm going to try to kind of draw this like a wave here. Okay, these things are all becoming one super atom at super cold temperatures. There they are. And that turns to a super fluid. Okay, and then these all kind of, I don't know, dot this around here. All becomes one kind of super atom, all these little atoms. So there's Bose-Einstein condensate. We need to add him on there just because he's part of this whole equation. Now I got a few more things to add, okay? Good job so far. We're going to go right from a solid to a gas. Remember that? So that's increasing energy. We're going from a solid directly to a gas. And then there is the opposite, okay, which was not a vocab word. Going from a gas down to a solid. So from a solid directly to a gas, we're skipping the liquid state. That is called sublimation, if you remember that. Sublimation. This also has a name here. Going from a gas directly to a solid. All right, let's say something just gets in a super cold state. Going from a gas directly down to a solid is called deposition, if you want to know. It's just to complete that thing there. All right, so there's that. So deposition would be cooling things down, or at least slowing things down. Sublimation would be speeding things up. Remember, the red is speeding up, the blue is slowing down, in a way. All right, so if we look at this, I don't know, I'll shade this guy in a bit because I used green for the atoms. All right. We have the states of matter. All right, let's look through it again. Make sure you can all see this on the screen. We have solid, liquid, gas is where we started. The change from solid to a liquid is melting. Change from a liquid to a gas is vaporization. We go from a gas down to a liquid, and we get condensation. We go from a liquid to a solid, and we get freezing. The different particles behave different ways, don't they, as they go through these states of matter. Now we go to gas and we electrify it. So, you know what? Why don't I add a little lightning bolt in there just to remind us we electrify this gas, okay, in this process, and that makes a plasma. All right, so the name for that, changing from a gas to a plasma, is ionization. The name for a plasma turning back down to a gas is deionization. Let's look back here. Solid going directly to gas, like dry ice, is called sublimation. Gas going down to a solid is called deposition. Okay? Then we have this guy off to the side, the Bose-Einstein condensate. When we supercool something, we're really down in this, down near absolute zero. Okay? We're down near absolute zero here. Maybe we need to add that. So let's just write near absolute zero, just to kind of let us know. And that would be 0 Kelvin degrees. 0 Kelvin. And that's where you get this Bose-Einstein condensate, superatom, superfluid. If you want to write that term as well. It's a superfluid. So there is your chart for the states of matter. Study it. Use it. I think we've included everything on here. Let me just check my notes here to make sure we've included everything. Yeah. Yeah, here's one thing we can add, actually. I've been mentioning this, but we can say this. Up here, maybe we can add a little arrow here. And this would be increasing energy of the system. I'll use capital E for energy. And if you want to shade that in red to remind you, that's fine. So if that's increasing energy, if we look this way, that would be decreasing energy of the system here. Okay? And we'll add one more thing. When we're increasing the energy of the system, right? Increasing energy, we are speeding up the particles. So particles speed up. Right? They go faster. That makes sense. Higher temperature usually when that's with that matter. And then here, on decreasing energy, particles slow down. Thanks for bearing with my handwriting and stuff. I'm standing up sometimes to do this and make sure it's looking all right. But there is your lesson for today. So what I want you to do, if you could please, after you've made this, on the assignment, I want you to take a picture of your chart that you've made with the states of matter and the different state changes. Take a picture and attach that on Google Classroom on the assignment so I can see that you've done this. And then, start thinking about how these change from one state to another. Use this to study. All right, and you'll also be able to use this sheet on future quizzes. Okay, so that's about a 20-minute little lesson there. Thanks for paying attention. Thanks for following along. And I will see you later.